Okay, today is lesson 2.2, day 1, and this is just review. We're going to really get into domain and range today and domains of complicated functions. But this is a review question, and the review question A, B, C, and D all should be pretty easy for you. I'm going to save us some time and go right to where people usually struggle. Get to B and part 2 of B. Everybody knows you're supposed to put in a 2x when you have like this part. So would you just do the next part? Do this part, and let's see if you know what to do for that. F of x is that big red function at the top. Well, f of x is just that. So by saying 2 f of x, they're just saying 2 times all that. So you should have said negative 2x squared plus 6x plus 8. And then some people went and factored the 2 back out again. Does that make sense in this context? No, we just multiplied it by 2. You don't want to factor the 2 back out. You'll get the same thing as you had to start with. Now, I have said that if you can factor it, you should. But in this case, it just gives you the original problem back again. So I'd say leaving it this way is probably the best way. Raise your hand if you had that one right. Okay, good. Now, I'd like you to try this one right here. You're going to, f of x, you already know what f of x is. All you got to do is figure out what f of h is and subtract it. I'll pause while we give that a shot. So f of x, we all know what that is. It's right up here. That has to then have something subtracted from it. Well, f of h means I'm supposed to put an h in, that's the x spot right there. So I'm sticking an h right there, and then I end up with f of x original, negative x squared plus 3x plus 4, and then minus, notice what I'm doing here, I'm putting it in parentheses, because this is a variable. F of h is kind of like y. You know, f of x is like y. So it's like a variable. So I'm just going to put a variable parenthesis there. Now I'm going to drop in what f of h is. That's an h going in here and here. So it's negative h squared plus 3h plus 4. And now that negative, this is what it was all about really, is can kids notice that you have to distribute that negative to all 3 parts. Final answer, this becomes positive h squared. This becomes negative 3h, and this becomes negative 4, which will cancel the positive 4 that's right here. Okay. And then, once the positive 4 and the negative 4 get canceled, I look for anything else that can cancel. I don't think anything can, so there's my answer. Negative x squared plus 3x plus h squared minus 3h. How many of you got that one right? Okay. Now, last thought. What's different about that one? Yes. Y is equal to 4 instead of x. Excellent. So I'm not going to put a 4 in the function. Where do I put the 4? In front. Because it says f of x is all that. And if they say f of x is 4, then that means that is a 4. 4 equals all that. Can I just factor it and set it equal to 4? No. If you're going to do that factoring trick, and you'd always be setting it equal to what? 0. So the first thing you'd do is subtract 4 from both sides. Then you'd have 0 equals negative x squared plus 3x. Then, if you can factor it, you should. And you can. And so then you should. So then it's 0 equals, what comes out of both of them? I would say negative x. You don't have to do it that way, but it's a smart way to do it. X minus 3. And then my 2 answers are x equals 0 and x equals 3. Notice I had to get the 4 off of there first to make it equal to 0 here. All right. Next. These are funny little functions that are like super easy and yet are going to count for like R3 level questions. The only thing that'll mess you up on this is you might do these in the wrong order. The in sequence is important. You have to have them in order. So it's saying the function we make has to add 4 first before it multiplies. But wait a minute. Doesn't multiply always come before add and subtract? Yeah, unless you use what? Parentheses. So write me a function that would do this. And call it g of x. G of x is what? What would do that? Write me a function. And then once you've written me the function, you just got to stick 5 in it. So write me the function, and then stick 5 in it. So g of x equals, well, I need an x, and I need it to add 4 first in parentheses, and then I'm going to times it by 3. Doesn't matter if I put the 3 in front of it or after it, the parentheses will force the adding to get done first. Raise your hand if you caught that. Okay, good. Now, you just got to stick a 5 in it. Stick a 5 in there. Do you get that I'm adding 4 first? 5 plus 4 is 9, and then I can times by 3. So then it makes 27. Raise your hand if you had 27. Okay, good. That's all there is to it. This next one's a little more wordy because it's got a f of x function, and the new function they want you to make is called g of x. But it still uses the same function here, except you've got to do these two things in order to it. So your new function is g of x equals x to the third, and then do this and do that. Go ahead, tell me what you think the g of x function really should be then. If you've got a first, multiply whatever you had by c, and then take that and add t. Just make sure you do it in the right order. That's the only thing people do wrong on these, is they write their function, but their function doesn't do it in the right order. Okay, so how am I supposed to multiply by c? Well, times it by c. You can put a c in front, you can put a c after it. Doesn't matter. How many of you got that part right? Okay, good. Then I got to add t plus t. There's my function. Now, where it gets a little weird is find g of 5. Where am I supposed to stick the 5? In the c or the x? The x. C is a constant. C is some number that we're going to multiply by, but we don't know what it is. So we stick the 5 in the x. Remember, this is the x spot. So I'm going to stick the 5 in there. I'd have c times 5 to the third, which is 125, plus t. They never told me t. They never told me c. So I have to leave them in there. Does that make sense? All right. And then the last one is find g of c, and then subtract t. I know it's weird. It's got a c in this, but that's the x spot. I'm going to pause while you give that one a try. Okay. Should have stuck the c in where the x goes. So c goes here. Then you end up with c to the third times another c, which makes it c to the fourth. C to the fourth plus t. But then I have to subtract t. Notice I got all done with the other part first. Now I'm subtracting t. It didn't say to stick a c minus t in the equation. The c minus t would have had to have been in there to do that. So this is a different thing. You subtract t later, and that cancels that, and I'm all done, and it's c to the fourth. Raise your hand if you had that one right. Okay, good. Moving on. Different kind of problem that we have to worry about now. This is the same kind of question right here as what we were just doing a second ago there, but I'm not going to do that for practice. I'm going to briefly talk about the difference between these two. This is really important. I want you to just stare at this and try to figure out what's different, because let me tell you, their graphs are different. They mean different things. Subtle. One of them means this, the other one means that. if I hadn't told you there was a difference, many of you, at least half, would have thought that they were identical. There is a difference. Who can tell me what they think the difference is? Only 3 people feel confident enough? 4, 5, 6. All right. F. I'm not saying names on the video. Go ahead.
The first one on the left.
Yep. Set equal to 0. So what's the difference? Can't you just always do that?
No.
What is the difference then?
The other one is set equal to y.
That's a y, and this is a 0. They're different. So what's the picture going to look like for both of them? Can you tell me that? Not exactly, but kind of.
The first one's going to be
Just the x-intercepts, yes. This is just where the x-intercepts are because y is set equal to 0. So this is just 2 dots. And by the way, where are they? 0 and 4. Those are just 2 dots. That is not a parabola. That one, does it also have the 2 dots? But it also has the whole rest of it. All of it. So it's got that, and it's got everything else in between. Do you get the difference? This one has been set equal to 0 and therefore is telling you if y is 0, the x-intercepts only. That one isn't just 0. You could set y equal to 0. You could set y equal to 1. You could set y equal to 2 and find all these different points. And you'd end up getting a parabola that still goes through these. All right, so that's an important note. If it's equal to 0 here, you're finding just the x-intercepts. You can do that if you want. You can always stick in a 0 and find the x-intercepts. But on an equation like this, you've got a whole bunch more stuff too, besides just those spots. Okay, good enough. Here's a bunch of functions you probably already know. Do you remember the y equals x function? Notice it says f of x, but that's the same as y equals x. All right. How many of you feel like you got that one down? You've seen it before enough times. Okay, good. How about this guy? You remember this guy? All right. That's 2 of the 12. Here's number 3 out of the 12. How many of you guys remember this one? Okay, good. You kind of have these down as like if I say what's x to the 3rd look like, you got to be able to sketch it like that. Okay. The 4th one's a little tougher. This is the fraction function. It's got the asymptotes that run here and here. Try to remember that that's 1 over x. Did you notice in our homework the other day it had a 1 over x plus 1? That's this whole thing except shifted where? And I bet a lot of you didn't recognize that, did ya? Okay, but do you recognize it now? You remember it now that you see the whole picture? Okay, good. That's one of those functions that you're kind of just barely familiar with it. I get you haven't done it a lot, but that's one you've got to know this year. Okay, out of the 12, that's one of the 12. How about this guy? You remember this guy? Square root function. Good. Notice it doesn't go this way. Why doesn't it go that way? Negatives under square roots can't do it. Okay, good. The exponential function is called the sorry, I said that badly. E is in the exponential function, and it's just e to the x. If you have an x in the exponent, you have an exponential. You had a small unit on this last year where you saw e. How many of you remember hearing about e? Okay, good. Then if you move on to this one, this is log base e. ln. Does that ring a bell? All right, good. So those are all things you've seen before. These are the main new ones this year. We got sine, which is a wave, goes up and forth, back and forth, oscillates between -1 and 1. And the big difference between sine and cosine, notice this one starts at the origin. It goes through the origin, whereas this one peaks at the origin. Okay, cosine has its peak at the origin, and the other one just goes right through it. So cosine is a peaker. All right, this one, absolute value. Remember this guy? All right, so you got a lot of these functions down already. The 12 biggest, most important functions of pre-calc. This one is the greatest integer function. grint is a way I've seen it abbreviated. Int x is another way. And that just means the answer always has to be a whole number. But technically not, because whole numbers are only from 0 and up. If this was the whole integer function, it would only be those. What's different about integers? They're a lot like whole numbers, except they can also be, they can be negative and thus any real number, yes. So these are all like whole numbers, except they're negative whole numbers. So when you include them in, that's called integers. And this function just can't be anything in between. It jumps right from being like it's 2, it's 2, it's 2, it's 2, and then it just skips right up to now it's going to be 3, 3, 3, 3. Now it's going to be 4, 4, 4, 4. It never is anything in between. You cannot connect this one with like a line. All right, moving on. Logistic function. It's cool because it has a peak. It has a limit. Can you imagine a terrarium where you're raising little frogs? You imagine if you have a terrarium, you might be able to hold 1 frog in there and he's happy. Maybe 2, maybe 3, but there's probably a limit to how many frogs you could happily raise in this certain size terrarium. This is a good real life kind of function because there are limits a lot of times. Like a pasture land, if you're going to live just off the food that comes off that land, only so many people can probably live there because there's only so much food. Another one's deer. Deer and like eating stuff in our neighborhoods even. If it gets really, really cold and they have only a few things they can find to eat because they got to scratch the snow off of it to try to get to grass, or they got to try to nibble on branches if they're really desperate, only so many deer can survive. There's limits. See, there's a limit on the top to how many can be supported in that area. All right, moving on. These are the list of the 12. I'm not going to relist them right now, but those are the big 12 that you eventually have to know. I just wanted to give you a little preview of that today. You don't have to like know them all tomorrow. If you wanted somebody with HIV, if you wanted to kill the HIV in them, or West Nile, or Ebola even, we could do something to you that would kill all of those things. Heat you up to about 107 degrees. That's all you'd have to do. What's the problem with that? It would kill you too. Exactly. And it's true that you can kill a lot of things by heat. In fact, when you get a temperature, you've heard of that, right? You know what your body's trying to do? Heat itself up on purpose to kill off a thing that's invading you. Okay? Your body does that on purpose to try to kill off invaders. So if you could heat you to like 107, it would kill off all of those. But it would also kill you. So it's not a great treatment. But the point is just to be able to talk about what will kill functions. You stick certain things in there, they can't handle it. They die. They explode. They turn inside out. They can't possibly work. Like for instance, if I put in a 1, it's fine. You get how I'd have 4 minus 3 is square root of 1. That's fine. It works. But what automatically would kill it? 2. Stick a 2 in there. If I stick a 2 right there, I have 4 times negative 3 times 2 is 4 minus 6. And that's negative. I can't have a square root of a negative. It dies. So this is about trying to figure out for functions what it can safely handle. Human being, can we handle volts of electricity flowing through us? Absolutely. You have electrical charges going off in you right now. Your heart. Your heart has got a rhythm to it that is your body sends it little shocks to like tell it, your heart to beat. Okay, and you can reset that with a pacemaker. Have you guys heard of a pacemaker? So a pacemaker can do those shocks for you and keep your heart moving at the right time. All right, so we have little shocks going off all the time. We can handle a certain amount, but we can't handle too much voltage. Well, these have certain requirements, and I'm going to give you a list right now, and you should take really good notes on this. If it has a square root in the problem, take good notes because this is what it's all about, and this is what our next test, which by the way is coming on Friday. We're talking tomorrow's the review day, and the next day is the test. This is one of the last hard things I got to teach you, and then we have review tomorrow, and then the test. If you have a square root of like this, square root of 3x plus 2, you have to be able to tell me what is safe to feed this function. We feed them numbers. Now, we were talking about temperatures for the human body, and you can make functions for all that too, but the functions are just simple. You feed them x, and if whatever you put in for the x, some things are safe for it, some things aren't. And so a domain is what's safe to feed this function. All right? So when it has a square root, do you get there's danger of possibly killing your function? Because you might put a negative under it by accident. All right, so here's the rule. You take the under root. I thought it was just a fun word. The under root. It's actually a name for it that you probably don't know. Okay, but if I said that radicand, you're not going to know what I mean. But if I say the under root, do you get what I'm talking about? The thing under the root. You take the under root and you set it greater than or equal to 0. Think about that for a second. If I can force what's under the root to be positive or 0, my function will be fine. So I take the under root right there, and I force it to be greater than or equal to 0, and I solve, and I figure out what's safe for this function. How would I start solving this thing? Don't plug anything in. Solve it. Minus 2. And I get 3x is greater than or equal to negative 2, and now what? Divide by 3, divide by 3, and x is greater than or equal to negative 2/3. So if I put in a negative 2/3, it's going to just barely be okay. Or anything bigger than negative 2/3. Let me show you why. Because if I stick in negative 2/3, guess what I end up getting? Exactly 0. And 0 is the smallest square root that there is. The square root of 0, this is important, the square root of 0 is okay. It's not breaking a rule. Square root of 0 is just 0. Because 0 times 0 makes 0. So the square root of 0 is fine. As soon as you go negative, though, then your function dies. All right. So this is the domain of this. The domain is the safe things to feed that function. All right. Do you get that it's safe to feed it a negative 2/3 because when I do, it ends up being square root of 0, which is equal to 0, and it doesn't fail? So what would be not safe to feed my function, for example? Something that's smaller than negative 2/3, like even negative 1. If I feed it a negative 1, I put a negative 1 right in here, I'll have negative 3 plus 2, which makes negative 1. The square root of negative 1, can't do it. It's actually odd. Very good. But it is an imaginary number that you made up. All right. So that's the domain when you have a square root. How else can you kill a function? Something you could feed a function that causes it to croak, besides making square roots negative. Yes? You can have lots of variables, and that's not a problem. Yes? Yes. This is a function. It's safe to feed it anything except for one thing. My dad was allergic to broccoli. He could eat anything else except broccoli. If he ate broccoli, his tongue would all swell all up, and he'd get, you know, I don't know what it is, but for something in broccoli would get him. And some people are allergic to peanuts. Some people are allergic to whatever. I'm sure you guys probably have some allergies in here. Sometimes it's low-level stuff like you just don't feel good, and other times it's like really serious, like literally. You've seen the dog around, and that's a guy who's got a peanut allergy, and it's like serious, like eat one peanut and you're in big trouble. I've even heard of situations where people that have severe peanut allergies, if they touch the desk and the desk had peanuts on it, that they can get severe reactions to that just from touching the same surface it was on. So again, there's an allergic reaction on this function to the number what? -5. But when it's more complicated and it's like this, and then I'll just make it like that. then all you have to do is the other one you set greater than or equal to 0 because those are what's safe. This, you set the denominator to be not equal to 0. This is weird. You have never set an equation with not equals before and solved it, I don't think. You tell me, have you ever? I know you've seen the not equal sign, but have you ever solved an equation with a not equals in it? All right. On your free time? All right. So you just solve them like the other normal kind. Just subtract 5 from both sides. 2x is not equal to negative 5. And then you divide by 2. X is not equal to negative 5 halves. And I'm going to make that even simpler. X is not equal to negative 2.5. So anything else you can feed this function except that one thing. All right. So that's called the domain of this function, is that x cannot be that. Domain is about x's, right? And domain is what can you safely feed this function. Domain of that function is x cannot equal 2.5. All right, so let me give you a weird one. 1 over 2 minus 1 over x. This has two things that could kill this function. I want you to try to figure out what the two things are that would be unsafe to feed this function. One of them you'll probably get right away. The other one you got to think about. Notice you have two denominators going on here. Would you please put your answer in the form of a number line? I want the domain for that function in terms of a number line. For some of you, this is going to be too much, but at least give me one of them. If you can't find both, I'll pause for a second and give that. All right, so here's what you should have been thinking. Well, Mr. Server said to take the denominator and set it not equal to 0. 2 minus 1 over x should not be equal to 0. Okay, how do I solve that? Well, it's got an x in the denominator. Do you remember me telling you on the top 20 how to get rid of denominators? Multiply everything by the denominator. So you multiply everything by x. I multiply this by x, and I multiply this by x, and I multiply that by x. 2x minus, that cancels that, 1 is not equal to, what's 0 times x? 0. So 2x not equal to 1, x not equal to a half. Why is a half such a big deal? Because I'm going to put it right here and watch what happens. 1 divided by 1/2 is like one cookie divided into halves, which makes 2. And this becomes 2, and 2 minus 2 makes 0, and the denominator has become 0, and the function dies. All right, but that's just one of the things. It can't be a half. And what else can't it be? Who thought a different level on this? What do you think? All right. Why can't x be 0? Just look at it. You see why? You'll have a 1 over 0. 1 over 0 is not allowed. In case you haven't figured this one out, 0 on top of a fraction's okay. 0 on the bottom, not okay. I can give you a nice long explanation for that one, but for right now, 0 on the bottom, not okay. I'll give you a shortish version of the long story. Can this equal 0? Well, let's cross multiply. Then x times 0 has to equal 1. Is that possible? No. Can't make anything times 0 equal 1. So therefore, x can't be 0. All right. So if I can't make that equal 0, there's no way I can make that work. All right, another way to do this is, what was my rule? I should always be able to go back to rules. My rule was take the denominator and set it not equal to 0. Well, this is the denominator. It's just a denominator inside of another denominator. What was I supposed to do? Take the denominator and set it not equal to 0. So x not equal to 0. There we go. So here's a half. Here's 0. Can't be either of those two. But I hope you wouldn't have just left your number line that way. Your domains are not a list of things that don't work. Domains are what is safe to feed this function. Everything else. So again, a bad answer to this would have been, kid says, x cannot be 1/2 and x cannot be 0. Okay, but it's the right answer is everything works except that. So the way we do that to make your life a little easier is you can say that, but you have to say all real numbers, comma, where x is not 1/2 and x is not 0. Another way to do it is just make me a number line. There we go. I like number lines for this. In fact, I think it's the easiest by far. All right, so let's look at some of your homework together. Everybody look at, there's a whole bunch of example problems there. Right here is the first day of the homework, and I said we were going to do page 1 and page 3. All right, here's page 1. So this, but wait a minute, Mr. Server, you told us about square roots can crash functions, and you told us about denominators can crash functions, but that's the only thing you told us about. That's because that one can't be crashed because it doesn't have a denominator and it doesn't have a square root. So if they don't have either one, then you can say, okay, then I can't crash that one. Put in any combination of numbers and it can be okay. You'll never fail. It won't ever get poisoned. All right, we'll let that out a second. This one, it's got a denominator. So I set it equal to, not equal to 0. X plus 1 not equal to 0. X not equal to -1. But then a lot of people are like, but it can't be 2 either, can it? Can the top be 0? Yes, it can. So don't say that 2 is poisonous. 2 is not poisonous. 2 is fine. Just x is not equal to 0, but you should put a big R next to it and say, really, the answer is all numbers work except -1. All right, so I've done the first couple for you. This one freaks people out sometimes. They're like, I can't figure out what makes it equal 0, because why? Yes, sir? Yeah, because what would have to be true to make that equal 0? This part would have to equal what? -3. Can you take something and square it and make it equal to -3? No. So you can't make that equal 0. So does that mean nothing works in this function? What can you safely feed this function then? Anything, because nothing will make the bottom 0. So nothing will hurt it. Nothing will crash it. This is the first one where we have a square root. How do you do those again? You set the under root, what? Greater than or equal to 0. Because we want this to be bigger than or equal to 0. All right, moving on. The second page. You know what? I have to give you one of these. Do 49. It's a very lucky number. 7s are lucky in the first place. 7 sevens. How can you get any luckier than that? Do number 49. You need one of those for practice. Last hour I had no time. You're going to have a little bit, and I had way more time to explain it to you too, so believe me, you're getting a good deal. Hour 1, if you're listening, I apologize. It was way too short. And then this page. And this page is actually, you know what? I'm changing it up. You are not going to like that page. I'd rather have you just do these 2 pages. Do the first 2 pages. Skip the other stuff. I'm going to explain the other stuff tomorrow. No, do all of the first 2 pages and none of the rest. You don't have to do page. I was wrong. I could have assigned it. I'm just saying I don't think that's wise. I should just give you the first 2 pages. So then the only thing left, I got one little thing to show you tomorrow, and then that's part of our review for the test. At current pace, test is on Friday. I can still change my mind, but I won't change it to move it up. I would only move it back and give you more time if I feel like it's not going to be, you guys aren't going to be ready for some reason. So, all right, that's all I got for you for the video for today.